So now let's do the next question. Find the value of ZL that will transfer maximum power from the source. Also find the maximum power. So this is the question, right? So here you have the load impedance in the middle of the circuit, and of course you're going to remove that, and then the voltage across this, open voltage across this, is called as the VTH. Okay, and one interesting thing about this circuit is that there's a dependent source over here. Okay, there's a dependent source, so we should consider that also. So let's do this question. First, to find VTH. Okay, so to find VTH, here's your resistor, here's the voltage source, and this branch is open, and the open voltage across this branch is called as VTH, and this is your inductor, and this is your dependent source. Okay, so what is Vx? Vx is the voltage across this 4 ohm resistor. See, the polarity, the potential is given. This is a sign. This is positive and this is negative. The value of the resistor is 4 ohm. This is a voltage source, and this is the positive terminal. This is the negative terminal of the battery, and this is 100 angle 0 degree. 100 angle 0 is 100 itself. This is 10J. Okay. So the same way, how we do this question, the same way, right? This is I1 and this is I2. Okay, and the branch across the current, this branch is open, therefore current through this branch is equal to 0, and the name of the current through this branch is I1 minus I2, which means I1 minus I2 is equal to 0, therefore I1 is equal to I2. Therefore this means that the current that is flowing through this 4 ohm is the same current that flows through 10J. That's what it means. Okay, that's all. This entire mesh, current only flows through. No current will flow through. All the current will flow through this outer circle, this outer branch. Okay, that's what it means. So I'm going to apply mesh analysis, and first I will apply the equation over here. So what is the equation over here? It is let me see, it is I1 into, okay, I1 into 4. Before that, what is the equation for Vx? I forgot to say. What is the equation for Vx? See, because first, if you see a dependent source, over here, first you need to write the equation for Vx. You need to find the you need to write the equation of the dependent factor over here. So here the Vx is the dependent factor, so you should write the equation for the Vx. So what is the equation for Vx? See, you can see over here, Vx is the voltage across this resistor, and if you want to know the voltage across the resistor, it is nothing but the current across the resistor into resistance, right? V is equal to IR. So what is the current through this resistance? It is I1, and what is the resistance is 4 ohm. Okay, and is it plus V1? Is it plus I1 or minus I1? Look over here. This I1 current is flowing from a higher potential to a lower potential. See, it is going from top to bottom. Sorry, it is going from bottom to top, right? It is going from bottom to top. It is flowing from a higher potential to a lower potential. So in that is what a current is supposed to do. The current across an element, across any passive elements, across a resistor or capacitor or inductor, it should flow from a higher potential to a lower potential. So therefore this is a higher potential, this is a lower potential, therefore current is flowing over in this direction. Therefore the equation for Vx is equal to 4I1. Okay, so wherever you see Vx over here, substitute that as 4I1. That's all. Now let me write the equation over here. So here you have I1 into 4. Okay, I1 into 4 and plus, now what is the voltage over here is VTH, right? VTH, and this current I1 is flowing from a higher potential to a lower potential. So therefore it is plus VTH is equal to, what about the voltage source? This voltage source is that it is flowing, this I1 is flowing from bottom to top, right? This current I1 is flowing from bottom to top, which means this positive terminal is, the current is flowing out of the positive terminal, or this positive terminal is generating I1. This voltage source is generating I1. Therefore it is plus 100 angle 0 or plus 100. Okay, this is the equation. I1 into 4 plus VTH is equal to 100. This is the equation. What is the equation? Now you write the equation over here, and equation over here is I2 into 10J. Okay, I2 into 10J minus VTH, because the current I2 is flowing from a lower potential to a higher potential. It is flowing from bottom to top. So it is flowing from a lower potential to a higher potential. So therefore it is minus VTH is equal to, and what about the voltage source? This current is flowing into the positive terminal of the battery, right? It is flowing into the positive terminal of the voltage source. So therefore, which is not what it's supposed to do, right? This positive terminal is supposed to generate current, but here it is opposing I2, right? Because the current is flowing into the positive terminal. So it is minus 5 Vx, okay? Minus 5 Vx. But we already know, if I see Vx, if you see any factor, dependent factor, you should substitute that. So here Vx is equal to 4I1. So therefore, this is nothing but minus 4 into 5 is 20, so minus 20 I1. Okay, so therefore the equation is I2 into, if you bring it over here, this will become 20 plus 10J minus VTH is equal to 0. This is the equation. Okay, or in other words, I can say that VTH is equal to I2 into 20 plus 10J. Okay, but I2 is equal to I1, right? Because this branch, there is no current through this branch, therefore I1 is equal to I2. Therefore this is nothing but I1 into 20 plus 10J. Okay, so then we can substitute this equation over here. So therefore you will have I1 into 4 plus I1 into VTH over here, right? VTH is I1 into 20 plus J. So 20 plus 10J is equal to 100. Okay, or in other words, I1 is equal to I1 into 4 plus 20 plus 10J is equal to 100, right? Or in other words, I1 is equal to 100 by 24 plus 10J. This is the equation for I1. I1 is equal to 100 by 24 plus 10J. Or in other words, VTH, right? VTH is equal to I1 into 20 plus 10J. So I1 into 20 plus 10J, but we already know what is I1. So therefore, VTH is 100 by 24 plus 10J into 20 plus 10J. Okay, which means, let's use a calculator, which means VTH is equal to 100 into 20 plus 10J divided by 100 into 20 plus 10J divided by bracket 24 plus 10J, and you will get 100 into 20 plus 10J divided by 24 plus 10J. So you will have 85.799 plus 5.917J, or this is also equal to option. In polar form, it is 86.003 angle 3.945 degree volt. This is the equation for, or this is the value of VTH. Okay, now I'm going to find the value of ZTH. So to find ZTH, see, usually we know normally the method of finding ZTH is that if you see a voltage source, you should short it. If you see a current source, you should open it. But here in the circuit, there is a dependent source, right? There is a dependent source. So if there is a dependent source, you cannot find the value of ZTH in that manner. In that conventional manner, you cannot find the value of ZTH. The only way of finding ZTH is by applying the equation ZTH is equal to VTH by IN, where VTH is the Thevenin's voltage and IN is the Norton's current. Why? Because this circuit consists of a dependent source. So if this is a dependent source, you can neither short it nor you can open it. So therefore, the only way of handling this problem is by using this equation ZTH is equal to VTH by IN, which means you need to find the value of IN also in the circuit to find the value of ZTH. Okay, so find the value of ZTH. So how do you find the value of ZTH? The only thing is simply short it, right? Which means to find IN, we should find IN. To find Zn, we should find IN. So therefore, to find IN, this is the circuit. That is a resistor and a voltage source. Okay. So we know how to find Norton's current, right? That is, we take the two terminal and then we short it. This is A and this is B, right? We shorted at the current through this terminal is what we call as IN. Okay. This is an inductor over here, and then you have another voltage source over here. This is 5Vx, this is 10J, this is 4 ohm, and this is 100 angle 0 degree. Okay. So now you need to find the value of IN in this circuit. That is the Norton's current, IN. Why we are finding IN? Because we need to find the value of ZTH. And why are we finding the ZTH in this equation in this manner? Because there is a dependent source over here. So if there is a dependent source, the rule will change, right? The finding the ZTH is using this equation. So that's why we are finding the Norton's current. So this is I1, this is I2. In that case, the Norton's current is IN is equal to, let me see, this current is flowing in the same direction of I1. So I1 is positive and I2 is flowing the opposite direction. Therefore, I2 is positive, I2 is negative. Therefore, the current through this branch is I1 minus I2. So IN is I1 minus I2. Now I will apply the mesh analysis. So in this circuit, I1. First, what is we write the depending factor? What's the equation for Vx? Vx is equal to 4I1, right? Because this is plus and this is minus, right? This is plus and minus. The current is flowing from a higher potential to a lower potential. So Vx is equal to 4I1. Okay. So now let me write the equation for mesh 1. Equation for mesh 1. Okay, it is I1 into 4 is equal to 100, right? It's equal to 100. Why it is plus 100? Because the current is flowing out of the positive terminal of this 100 volt battery. That's why it is so. Therefore, I1 is equal to 25 amperes. Okay. Now equation for mesh 2. Equation for mesh 2 is over here, and here the I2, the equation is I2 into 10J, right? Here the resistance on the reactance is 10J. I2 into 10J is equal to, and this current is flowing into the positive terminal. This positive terminal is not generating I2, it is opposing I2. That is why it is minus 5Vx. Okay. So I2 into 10J is equal to minus 5Vx. And we know what is Vx. Vx is 4I1. So therefore it is minus 20I1. Okay. And we all know what is I1. I1 is 25 amperes. So therefore this is nothing but minus 20 into 25. So therefore the equation is I2 into 10J. I2 into 10J is equal to, and 25 into 20 is 500. So this is minus 500. Okay, minus 500. Or in other words, this is nothing but if we I2 into J, divide this by this, will become minus 50. Or in other words, if I multiply this with J on both sides, I will get minus I2 is equal to 50 minus 50J, right? Into J, now it is minus I2 is equal to minus 50J. Or in other words, I2 is equal to 50J. Right, I2 is equal to 50J. So therefore IN, the Norton's current IN is equal to 25 this I1 minus I2, which is equal to 25 minus, and I2 is 50J. 50J, this is the value of IN. Okay, and if this is the value of IN, and also I already found the value of VTH, right? This is the value of VTH. So I will find the value of ZTH. So ZTH is equal to VTH by IN, which is equal to, what is the value of VTH? VTH is equal to 85.799 plus 5.917J plus 5.917J. This is the value of VTH by, and the value of IN is 25 minus 50J. This is the value of ZTH. It is 85.799 plus 5.917J, close the bracket, divided by, here you have 25 minus 50J is equal to, so ZTH is equal to 0.592 plus 1.42J. Okay, this is the value of ZTH. 0.592 plus 1.42J. So now I can draw the Thevenin's equivalent circuit. This is my source voltage, this is my source impedance ZTH, and this is my load impedance ZL. Okay, so here the value of VTH is this value, or VTH is this value, 86.003. VTH is equal to 86.003 angle 3.945 degree, and the value of ZTH is, I will use this form because I can find the conjugate very easily, right? So 0.592 plus 1.42J. Okay, and this is the value of ZL. So since this is a variable resistance with variable reactance, is the value of ZL, to get maximum power, the value of ZL must be the complex conjugate of ZTH. Therefore ZL is equal to ZTH star, which is equal to 0.592 plus 1.42J. This is the value of ZL. Minus, sorry, it's plus, so it is minus. Okay, minus complex conjugate should be the complex conjugate of the source impedance. Therefore ZL is equal to 0.592 minus 1.42J. Okay, now if you want to find the maximum power, the equation for power is P is equal to magnitude of IL the whole square into RL. What is RL? RL is the resistance, right? The real part, because the imaginary part is basically your capacitor and inductor. If it's a capacitor inductor, there will always be a J right in front of it, but for resistance there will be no J, so this is the real resistance, 0.592. so therefore RL is equal to 0.592. Now you need to find the value of IL, which is the current in this branch, and we know that the equation for IL is IL into, if you are applying mesh analysis, it is ZTH plus ZL is equal to VTH, right? Is equal to VTH. This is the equation, but we all know what is the equation for VTH, right? I will use the other equation, this equation, the rectangular form, that is VTH is equal to 85.799 plus 5.917J the whole divided by, and what is ZTH plus ZL? That is, if we simply add up the two conjugates, 0.592 plus 1.42 and 0.592 minus 1.42, that is, both the imaginary part will cancel each other, so you will have 0.592 plus 0.592, which is 0.592 into 2, which is 1.184. so therefore this is by 1.184. so therefore what you get over here is 85.799 plus 5.917 J, the whole divided by 1.184 is equal to this value, that is 72.465 plus 4.997 J. Okay, and if I want to find the magnitude, that is magnitude of IL is equal to, simply find this magnitude over here, that is remove the angle, you will get 72.637. the magnitude of IL is 72.637 amperes. This is the magnitude of IL. So therefore the equation for power, right, the equation for power is P is equal to magnitude of IL the whole square into RL, which is equal to, and the magnitude of IL is 72.637. so therefore it is 72.637 the whole square into, and the RL is the resistor, that is 0.592, which is equal to 72.637 into 0.592. Oh, I forgot to put square in it. 72.637 the whole square into 0.592. okay, this is equal to 3123.471 watts. This is the value, 3123.471 watts. Or you can also say this is nothing but 3.123, right, 3.123 kilowatts. This is the value of power. Okay.